Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. It gives me great pleasure to welcome Dr. Don Easterbrook. He is a geologist who for the last 50 years has been looking at ancient and modern climate change and abrupt climate changes, looking at glaciers and the ice core analysis. He is the author of several books. He has looked at the causes of climate change, the correlation of glacial fluctuations, the Pacific decadal oscillation, climate and solar variation. He's looked at a 500-year record of temperature changes using oxygen isotope data from the Greenland ice core, the effect of CO2 on climate change, and geologic history of climate change. He has a lot to offer and a very unique perspective that we need to really listen to. Ladies and gentlemen, welcome Don Easterbrook to It's Rainmaking Time. Good morning.
Good morning.
I don't think that we would be able to easily get through your books, Surface Processes and Landforms and the Interpretation of Landforms from Topographic Maps and Air Photographs, a Laboratory Manual. It sounds like it's very technical for people who maybe need a frame of reference that's deeper than mine. What do you think?
I think that's correct. These are technical books that were written primarily for geology students at the university level, and it presupposes that you have backgrounds in physics, math, chemistry, and basic geology. So these are not things that are written for the layman. These are written for students of science in one discipline or another.
You say that the past is the key to the future regarding climate change. Talk to us about why that is and why a geologist has a totally different perspective when looking at climate change.
Well, I have always said that in order to know where we're headed in the future, we need to know where we've been in the past. And that's something that most geologists are pretty good at because we have a broader time frame over which we look at things. And one of the advantages that that kind of a perspective has is that it allows one to look for patterns that have occurred over decades or centuries or millennia or hundreds of thousands of years. And that gives a good look at where we really are in the long-term spectrum of the total changes that have occurred with climate over long periods of time. And it's a lot different because it also is based on real-time, real-world physical evidence rather than on computer modeling, which, as you know, is garbage in, garbage out. And so most geologists base their conclusions on real evidence that you can measure, that you can see, that you can work with, and real data rather than some kind of computer-based scenario in which you have to make a lot of assumptions. So we would like to think that we're closer to the way the real world works rather than the way some computer thinks it ought to work.
Now, in the context of understanding climate change, because there's so much politics, as a geologist, when you're looking at data, real-world data, how do you know the data hasn't been hampered? How do you know you're getting clean data from real-world testing sites or measuring sites?
Well, it has to be reproducible. That is, you have to have assurance that what you're seeing is, in fact, true. There are various problems sometimes with respect to the way people view the data, but the data shouldn't change. And one of the problems that is now being experienced by those people who are working with climate change is that with respect to short-term climate changes, mostly global temperatures, that the data has been so badly manipulated. This came out in the ClimateGate scandals in England, that it's hard to know really what you can trust and what you can't trust. And there have been some studies made of how valid the surface data is, and what has been determined by experts in the field, by meteorologists, is that something like 80% of the weather reporting stations in the United States are not valid in the sense that they do not conform to the rigid specifications for a site recording. So can we trust the surface data? And the answer is probably not. So the only chance we have then to do better than that is to look at the satellite data, and that data is reproducible.
It is?
It's done by satellites. It's done by machines, so there's no personal bias built in, and it gives us a rather different picture than the picture you get from the surface data. So to answer your question, you have to evaluate how good the data is in some way, and one of the best ways to do is to test it. For example, if a computer model says it's going to be colder by 1 or 2 degrees in the next 10 years, and that prediction was made 10 years ago, we can check it and see if it holds true. Now, during that time, the data, the real life data, not the computer data, shouldn't change. I mean, data is data. Once it's done, it's done.
What about NOAA and NASA and relying on their translation of what's occurring relative to data? What do they do?
Both NOAA and NASA manipulate the data. For example, about a decade ago or so, 1934 was considered to be the warmest year of the past century. And then over a period of years, they manipulated the data so that instead of 1934 being about a full degree Fahrenheit warmer than 1998, which was the next in line, the NASA folks adjusted the data for 1934 downward and adjusted the 1998 data upward in trying to make 1998 warmer than 1934. And this data manipulation consists of throwing out stations, primarily those which have a cooling record, and in looking at the data globally, something like 60 to 80% of the weather stations that used to be reporting are excluded for one reason or another. Sometimes they're not even, these stations don't exist anymore. But then they average over large areas data that's accumulated from around the margins. For example, there are almost no recording stations in the Arctic. So they take some data around the fringes. It'd be like taking a temperature reading in New York and a temperature reading in San Francisco, and then trying to extrapolate from that what the climate is like over the entire United States. And then they cast this into various computer-type models and come up with some numbers. So the problem is that in almost all cases, both NOAA and NASA always adjust their data to make it warmer than the raw data.
How do we know that for sure? Don, how do we know that for sure?
Adjust things so that the data would come out being cooler. And this has been done all over the world. It's been done in New Zealand, Australia, in the U.S., and they call it homogenization of data. If you homogenize the data, you can come up with what had been previously a cooling trend in a temperature curve and make it into a warming trend. One of the most heinous of these was in Australia and New Zealand, where there was a cooling trend over a period of a couple of decades, and they adjusted the data and made it into about a 2-degree warming curve.
How do we know that? How do we know they adjusted it and changed it? That's, to me, the key question. How do we know that that's a fact?
Oh, because they have published the early data, and then we can see how it's changed. NASA, for example, published data sets going back to 1987, and then there have been various upgrades. And if you look at the original data in 1987 and look at their interpretation of that data today, it's quite different than what it was when it was recorded in 1987. So it makes you wonder about how objective this data manipulation is. And the people who are making these adjustments are noted for being adherents of CO2 caused global warming. So the people who are doing the manipulation have a pretty widely recognized bias.
Well, let's talk about, now that you're mentioning CO2, in some of your writing you talk about climate changes in the geologic record show a regular pattern of alternate warming and cooling within a 25 to 30-year period for the past 500 years. But you also say that numerous abrupt, short-lived warming and cooling episodes, much more intense than recent warming and cooling, occurred during the last ice age, none of which have been caused by changes in atmospheric CO2. Why?
Well, the data is very, very unequivocal, and it comes from world standard ice core data, and especially isotope data that is temperature sensitive. which was done by Minza Stiver at the University of Washington many years ago, and Peter Grutis. And it is a record that goes back hundreds of thousands of years, and you can take various bits and pieces of it, something like 20,000 measurements. So the data then, when you plot it out, shows that, and I'm looking at one of these curves now, for the past 500 years, there have been 40 periods of warming and cooling, none of which could have been caused by changes in CO2, because these changes took place long before there was any significant rise in atmospheric CO2. So you can't ascribe these to CO2 as a causative factor. And then if you go back longer than that, go back 15,000 years, the list of warming and cooling gets even longer and more intensive. For example, at the period from about 10,000 to 15,000 years ago, we know now that there were fantastic changes in climate. The past century is now probably about 1 degree warmer now than it was at the beginning of this century, which was incidentally a cool period. And so the total changes that have occurred in that 10,000, 15,000 year period amount to something like, in one case, 8 degrees centigrade, which is more than 10 degrees Fahrenheit, in 40 years. And the magnitude for some of these changes is like 20 to 25 times the magnitude of the rather small warming that we've experienced in the last century. And even in the last century, half of the warming that we have observed and been measured by recording stations, half of that occurred before the big increase in CO2, which began after World War II, and CO2 emissions began to soar. So we have all of these huge swings of temperature, global temperatures, without any possibility that it could be related to CO2 as a cause. And then if we look at the pattern, for example, the pattern over the last 500 years, shows that there have been 40 changes in the last 500 years, warm, cool. And the average of these changes, the average length of these changes turns out to be 27 years. Plus or minus the number, it varies from about 25 to 30 years, which happens to be the same amount of change that we've experienced in the past century. We've had 2 periods of global warming, 2 periods of global cooling in the past century. But if you listen to the news, you'll get the impression that, climate has never changed until the last 30 years or so when we had a warming trend. And that's just not the case at all.
So you're looking at everything in the context of cycles and not that there's this long-standing condition called global warming, correct?
That's correct. The hockey stick trick was a scientific fraud, and there were 3,000 papers that were published contrary to that conclusion, which is the main IPCC basis for their saying that CO2 is the cause of climate changes. And when we look at the data for long periods of time, we can see that the Earth's climate has been warming and cooling for centuries and millennia, with no possible effect from CO2. And then if we look at the pattern, we ask the question: if you look at the past history of climate changes, and see if there is a pattern, and there is a very definite pattern. There seems to be a switch from warm to cool about every 25 to 30 years or so, and you project that into the future. This is where the past is the key to the future. Then what we see is we're right where we would expect to be in that pattern.
And where are we now, Don?
We are in a period of cooling, or certainly a period of no warming, no significant warming. Since 1998, 1998 was the second warmest year of the past century, and you will see headlines. Matter of fact, there's a headline in the New York Times today that said that 2010 was the warmest year on record.
Absolutely not.
And,
oh my God.
And the joke about that, of course, is that it's based on manipulation of data again, and it's based on temperature records that are known to be biased, in some cases heavily biased. So the attempt to get some kind of an objective view is best done by looking at the University of Alabama satellite data, which shows that in fact the 1998 temperature was actually about a tenth of a degree warmer than the maximum temperature in 2010. So 2010 is not the warmest year of since 1979, when records first started accumulated by satellites. So you'll see headlines all the time about how this year or that year or this decade or that decade is the warmest ever. And then looking at a longer time period and asking the question, well, how significant is this? And it turns out that almost all of the last 10,000 years has actually been warmer than it is during the past century. So there's no correlation between geologic history and the claims that are being made for heating all the time. And of course, the biggest joke of all is the statements that are being made right now that global cooling is being caused by global warming, and the hotter it gets, the colder it's going to be. That's how they're explaining the incredibly cold winters that we're having in Europe and Asia.
It reminds me of the explanation for why all these birds have dropped to the ground dead. They said, they had bad digestion. It's about as crazy as that. Everything is global warming. Everything is, they had bad digestion, why hundreds and thousands of fish are dying. Interesting explanations. But here's my question to you. What is happening in Greenland with the ice sheets? And how come they're saying the ice sheets are breaking up? And how do you respond to that?
Easily. The data speaks for itself, and there are many, many claims that are being made, both in the press and by scientists who want to know better. And there are three areas of concern. One is the Arctic, the other is Greenland, and the other is the Antarctic. And so if we take those one by one, in the Arctic there is no ice sheet. It's an ocean. And so the only ice that's at the Arctic is floating ice, which is frozen sea ice. It's only a meter or two thick. And the claims have been made that sea level is going to rise 20 feet if the so-called Arctic ice cap melts. Well, A, there is no ice cap there, and B, it's floating, so if it melted, it wouldn't affect sea level at all anyway. And so the records are kind of scarce up in the Arctic and the North Pole area. There are better temperature records available for Greenland. So looking at Greenland, there has been melting of Greenland glaciers for about the last 30 years, something like that, no doubt about it. But the question is that unusual? And does it have any relation to CO2? And the answer is no, because there are records kept in various Greenland weather stations that date back to about 1900. We have a 100-year record. And each of those shows that there was a cold period from about 1880 to 1910, something like 1915. And then temperatures rose, reaching a high in the 1930s. And temperatures were actually higher in Greenland in the 1930s than they are right now. And the rate of warming from 1915 to about 1940-something, that rate of warming was greater than it has been over the past 30 years. So we're not quite yet to where we were in the 1930s. And then it cooled in Greenland from about 1945 to about 1980, roughly 1977. So the point here is that the glaciers in Greenland melt and advance in response to climate change, and the climate change is unequivocal for the past century in Greenland. It shows warming from the turn of the century to about 1940, cooling from then to about 1980, and then warming again. And it is exactly following the global temperature record and the temperature in glaciers all over the world. So there's nothing unusual about it. Now, as temperatures are cooling off, what we would expect to see is that we will soon see the glaciers beginning to advance rather than melt in Greenland. And the idea that you could melt the entire Greenland ice sheet is total nonsense. It would take a long period of time and with much more intense kinds of warming than we're seeing. So the third part of this picture is the Antarctic. And there have been claims that the Antarctic ice sheet is melting at an accelerating rate and it's going to cause dramatic sea level rise, which is absolutely contrary to the facts. There are weather stations at the South Pole and at Vostok, which is some distance away, but they're both on the Antarctic ice sheet, which is 10 to 15,000 feet thick in that area. And they all show that there has been no significant warming on the ice sheet since 1957. The record is complete from 1957 to the present, and if you draw a line through the changes, it's remarkably consistent with no appreciable change at all. The Antarctic ice sheet is not melting, and it's not surprising because the average annual temperature is about 58 degrees below zero Fahrenheit at the South Pole, and last year it reached in their winter temperatures of 106 below zero. Well, think about what it would take to melt an ice sheet that's 10 to 15,000 feet thick. You'd have to raise the average annual temperature 58 degrees to get to zero, add 32 degrees to get to the melting point of ice, and then you need about another 10 degrees in order to get any appreciable melting. You don't get any appreciable melting at 32 degrees. So we're talking about you'd have to raise the temperature in Antarctica 100 degrees to get any appreciable melting at all. The only melting that's occurring right now is on the West Antarctic Peninsula, which is a little finger that comes off the main Antarctic continent to the northwest, and is surrounded by ocean water, which has warmed somewhat during the last warm period, which was 1978 to 1998, and has caused some melting there, but it has not affected the main Greenland ice sheet at all.
When you get into the details, it makes sense. It really makes sense.
The secret is in the data. The data speaks way louder than all the rhetoric that you hear from biased scientists and from the news media.
Some people may say that you're a biased geologist. How do you deal with that?
Well, the first thing I would ask is, what are my biases? I think there's a significant difference here between what the CO2 dogmatists are saying and what the geologists like me are saying and other people who deal with climate. And that is, the data speaks for itself way louder than all of the opinions that the scientists themselves may have. For example, you can paint an unsupported hypothesis of some kind. CO2 is causing it, for example, and without any data, that's just a scenario which may or may not be true. On the other hand, if you look at real data, which is what we're doing, the data speaks for itself, and you don't need my opinions for anything. So whether I'm biased or not has no effect whatsoever on the validity of the data that forms a basis for my opinions. My opinions aren't important, it's the data that's important.
Yeah, I get that. But the fact is now that this subject has gotten so politicized and there's big money at stake, there's a whole agenda at stake. Wouldn't the weather stations also maybe be paid off or be influenced to play ball?
I don't know anything at all about that, and I think it would probably be impossible to assess. But what I do know is that Anthony Watts, who is a meteorologist, well-known meteorologist, has conducted a survey of virtually all of the weather stations in the U.S. This is not the world, this is the U.S. And what he found was absolutely amazing. He found temperature recording devices that were sitting next to exhaust vents on rooftops that were pumping hot air in the direction of the recorders. He found them at the end of runways where every jet that took off sent a blast of hot air, and all kinds of things. One of them was even over a barbecue. And what he found was 80% of the recording stations in the U.S. do not meet the standards for a surface recording station. And so then you ask the question, well, how good is the data then? And the answer is probably not very. And that's what both NASA and NOAA use as their starting point. And then from there, they further manipulate the data. So the validity of the data is a point in question. And so we have to look then at those data which give us an unbiased account of what actually happened. And probably the best record are the satellite records, because they are not human biased. These come from measuring instruments. They don't come from human-based kinds of recordings. So the big difficulty, of course, is that most of the claims that are made for global warming being caused by CO2 involve huge amounts of money, as you mentioned, and not insignificant trillions of dollars. And in addition, there is unfortunately a very strong bias in the funding agencies of the federal government. They spend, I think, something like $2.5 billion on climate-related research, all of which goes to the CO2 people, and none at all to objective-based, or very little, if any, to objective-based scientists who are looking at other possible causes of climate change other than CO2.
Right now, what you're stating in your declaration is that global warming is over. We are into the beginning of global cooling. Is that correct?
Yes.
Talk about why.
Well, again, we have to look at the past pattern and then project it into the future. And then we have to test and see if that kind of a prediction is, in fact, happening right now. So what I did in 1999, I looked at the past record of climate changes, warming and cooling, over the last 500 years, the last 1,000 years, the last 10,000 years, and so on. And I saw a distinctive repeating pattern with an oscillation of about 25 to 30 years. And then I looked at Pacific ocean surface temperature data. This is called the Pacific Decadal Oscillation, and it shows that the Pacific has two modes of temperature. One is a warm mode, one is a cool mode, and it flips back and forth like an on-off switch. It's not gradual. It will suddenly flip from one mode into the other mode. And so what I discovered was that in 1999, the Pacific switched from what had been a warm mode for about 22 years into its cool mode, and we have 4 of these changes that have occurred in the past century. And each time there has been a change in the mode of Pacific ocean water temperatures, we've had a global climate change. And part of that is that the same thing happens in the Atlantic Ocean. It's a little bit different, but the same general thing takes place. And so I put this all together, and I came up with a pattern that says, okay, each time in the past century that the Pacific has changed from its warm mode to its cool mode, we've had a period of global cooling. Each time it switched the other way around, we've had a period of global warming. It so happened that 1998, at that point, was the second warmest year in the century, and I predicted that if the same pattern held as had happened all during the last century and for the past 500 years, that we would be entering a period of global cooling beginning sometime after the year 2000. And people thought I was crazy because we just had one of the warmest years, second warmest year of the century. And it was based entirely on the geologic data, not on what was happening that particular year. Well, it turns out that we have not, despite predictions of a 1 degree increase in temperature every decade by the IPCC and by the CO2 dogmatists, we have not exceeded the 1998 temperature in the past, and now 13 years. And the overall trend is slightly downward. It's not strongly downward yet. And so my prediction, let's just take the year 2000, over that 12-year period, was that we should not experience more warming beyond where we were in 1998, but we should have some cooling, and it's happening. So the proof of the pudding is in the eating. What I predicted is indeed happening right now. If we ask the question, why is it happening? The sun is behaving very peculiarly. It hasn't behaved the way it's behaving right now since the last really cool period, known as a Dalton minimum, about 1800, about 200 years ago. So we're experiencing right now, we're in a solar mode that reoccurs about every 200 years. And we have entered that mode, which tells us then that maybe what we're seeing is the cooling effect of what's going on with the sun, especially with the sun's magnetic field, not just with the solar output, but with the magnetic field. And that gets into some technical things.
Would you explain a little bit about the magnetic field?
Sure. The sun has a very strong magnetic field, and what it does is it acts as a shield for incoming radiation from space. And we know that when there is radiation going through the atmosphere, that it ionizes particles in the atmosphere, and these serve as nuclei for condensation, or in other words, cloud production. So the more of this kind of radiation that goes through the atmosphere, the cloudier it's likely to be. Clouds are a great reflector of solar heat. And so the more clouds, the more reflectance of the solar energy takes place. Well, there is a satellite that goes around the sun, and it's accumulated now something like 17 years of data, and what they've measured is that the strength of the sun's magnetic field has been decreasing at a rather rapid rate over that 17-year period. And so now there is what's called a solar magnetic index, called an AP index, and it has gone down almost to zero. It goes down to a number of 3, which is compared to what it should be right now, which is about 50. Shows that the sun's magnetic field is very weak. And we know that during times in the past when this has happened, we've had global cooling. So there's every reason to believe that the change in the sun's magnetic field may have a strong effect on global climates. And that trend right now is cooling, not warming. And the last time this happened was 200 years ago, and we had a very strong cool period, 1790 to 1820, where all kinds of historic events were affected by the cooling. And 200 years before that, in the 1600s, there was a significant cooling called the Maunder minimum, which led to widespread reduction in crops in Europe, and a third of the population died from famine and disease. And so the question now is, with respect to the sun, are we heading for a minimum solar output, which is similar to 1800, or maybe even worse, like the one in the 1600s, for the next 30 years, or maybe even 50 years? We won't know until we get there. But the proof of the pudding is in the eating. Time will tell. And right now, time is telling us that the Earth is no longer warming.
So everybody that has been drawn in to the global warming scare and CO2 and the entire story about that is preparing for something we're not in the midst of. They're preparing to be climate refugees and heating up and the sea level rising. And all that preparation is the wrong preparation because we're in a totally different condition of climate change.
Yes, and the stakes are not insignificant. The stakes are huge because if you consider this, the predictions have been made by the CO2 proponents that we're going to have a 10-degree increase Fahrenheit in temperature by the end of the century, and that will be disastrous. If that were to happen, it would be disastrous. They predicted that we're going to have 1 degree per decade increase in temperature. But we've now had a full decade, we've had at least 12 years, since they made that prediction. So how well does their prediction match with what has actually happened? And the truth is that their computer projections failed miserably, that they were totally wrong. The temperature today is not 1 degree warmer than it was in the year 2000. So their models failed. That's a very important point because all of the hype that you hear about global warming is based on computer models, not on real life data. And if the climate is in fact cooling, as I have projected based on the various kinds of solar and geologic data that is available, if that's happening, you think about the consequences. As the temperature goes down, food production goes down. And that's happening right now. India is very cold this year.
Right.
It was cold last year. So is China. China had record-breaking cold last year. North America was cold. All of the continental areas of the northern hemisphere and probably also the southern hemisphere. But for the northern hemisphere, everything has been cooling, and that has reduced food production just in the last 3 years. Well, think about what happens if it gets worse. We have lower food production. There are millions of people primarily in third world countries that are at the brink of starvation already, especially in Africa, where a small difference in the food availability means a lot of people will starve to death. So if we're entering a period of global cooling and we have decrease in the food production, then a lot of people are going to starve to death. think about the energy consumption. What happens when the climate gets cooler? The per capita, per person, use of energy increases. You use more energy because it's colder. And what that means is that we're going to need more energy if the population were constant forever than we have in the past, just because it's colder. So the energy requirements are going to increase. They're not going to remain constant. And then you throw in the real joker, which is the real problem that we're facing right now, way more important than climate change, and that is population increase. The doubling rate for the world's population is given by various people in about 38 to 40 years. In other words, the population will double every 40 years. So by 2050, the population will be somewhere between about 9 billion and more than that. How much more is speculative. And so how are we going to feed and provide energy for 3 billion additional people over what we have now with decreased food production and no substantial increase in energy production? And it's a real calamity. So if we spend trillions of dollars, which is what it would cost, in a futile chase after CO2 in the mistaken idea that this will somehow affect climate, then we will have spent our money needlessly, and we won't have the resources necessary to cope with the very real problems that we're going to be facing.
Well, maybe that's part of the agenda. Maybe it is part of an agenda. Maybe not an obvious one, maybe not a stated one or a formal one, but maybe it's in there. Remember that a lot of the climate objectives began with the Club of Rome. I mean, you can't deny that. The agenda began in the Club of Rome as an agenda to catalyze and to create an environmental problem that was basically our fault.
Right.
I mean, this is in their written papers. So maybe it is part of the mix, and maybe that's what's going on. I mean, why would anybody create an agenda about climate, turn CO2, which is food for plants, into a boogeyman? Why would you do that? And then create a carbon system that has nothing to do with the cycles of climate. It doesn't make sense.
It doesn't make sense, but it makes sense if you look at the climate meeting that took place in Copenhagen last year and the meeting that just took place recently in Cancun, and the proposals that were made for world treaties dealing with global warming, climate change, CO2 production, that sort of thing. And if you read the actual documents, which were intended to be signed as a binding treaty by all nations that were attending that, including the U.S., what you'll see is that they were setting up a world government to be run by a secretariat of the UN, which was not elected, and all countries were to cede sovereignty, national sovereignty, to this UN group, so that we would, in fact, have a global kind of government that superseded all national governments. So if the Secretariat made a decision, it would supersede anything that the U.S. Could do, and these would be binding. And you think, my God, what a powerful kind of agency that would be. And then another part of that Copenhagen Protocol was that the so-called developed nations were to pay what was called a climate debt to the poorer nations in terms of a redistribution of wealth. The wealthy nations would have to lower their standard of living, and the present administration pledged $200 billion a year to go into this so-called climate fund, which is to be distributed to third world countries to try to increase their economic situation, which is a noble effort to be sure. But the whole idea was to redistribute the wealth of the world and to diminish the living standards of those developed nations and increase those of underdeveloped countries. So there's a very strong political bias background to the whole climate scare. And the basis for all this was that, well, if we don't do that, CO2 is going to cause the world to have a global catastrophe. Fear is a big driver in all this.
What's the relationship that CO2 has on the geologic conditions around the world?
Okay, some things that need to be upfront are factual and which are not disputed by any competent scientist, and that is that there is very little CO2 in the atmosphere. You get the impression from the news media that we're breathing pure CO2, or that there's a large amount of CO2 in the atmosphere, and the truth is that there are 38 1,000ths of 1% of CO2 in the atmosphere. Very small. 380 parts per million. For every million atoms of air, there are only 380 molecules of CO2. And so that has increased from about, 8 1,000ths of 1% increase in the amount of CO2 in the atmosphere since about 1945, which is when the CO2 emissions started to soar.
Why did they start to soar, in your opinion?
Oh, I think that it's very clear that it's the Industrial Revolution. I don't think anybody would bother to argue that, because the change is so dramatic. After World War II, if you look at the CO2 emissions, they just take off and they soar. They're way beyond what they had been previously, and that's because so many countries began pumping CO2 in the atmosphere as a result of the so-called Industrial Revolution. And so I don't think that there's a big argument about whether the increase in CO2 was man-made or not. I think, but the critical question is, how big is it? And you cannot escape the fact that there is only 8 1,000ths of 1% increase in atmospheric CO2 since 1945. That's indisputable. And so the question is, what effect does 8 1,000ths of 1% CO2 in the atmosphere have on climate? And then you look at the so-called greenhouse gas effect, and CO2 is one of the greenhouse gases. Of the greenhouse gases that make our climate warmer and comfortable, and it would otherwise be pretty cold, 95% is caused by water vapor, and only 3.6% is caused by CO2. So the big controlling factor of greenhouse gases is not CO2, it's water vapor, by far. Ratio of 95% to 3%. And so what effect does an 8 1,000ths of 1% water vapor have on a molecule, CO2, which is responsible for only 3.6% of the greenhouse effect? And the answer is almost none. And then if you look further at the physics of the CO2, CO2 in its absorption capacity of heat is something like a big sponge. And if you have a brand new sponge and you dunk it in some water, it will soak up a lot of water. And then thereafter, there's a limit to how much more water that sponge can soak up. Well, the CO2 that's in the atmosphere right now is pretty much saturated. And you can show with the physics of it that if you were to double the amount of CO2 we have in the atmosphere right now, it would have a less than 1/10 of 1 degree change possible in the greenhouse effect temperature.
Oh, could you say that again? That's so profound. Say it again for us.
Okay, I'm going to say it in bits and pieces.
Okay.
There is so little CO2 in the atmosphere right now that it is a trace gas. There's virtually none. And the rule of thumb is that if you double nothing, you still have nothing. So if we double the amount of CO2 that's in the atmosphere right now, what effect would that have on temperature? Well, the effect would be that the limit of CO2 as a greenhouse gas, it makes up only 3.6% of the greenhouse effect. And so its effect to begin with is limited to about 3%. 95% is water vapor. And so if we change that small effect of CO2, of this minuscule amount of CO2, by 8 1,000ths of 1%, is that going to cause a 10-degree change in temperature? And you can show the physics that it's incapable. And the bottom line of all this is that CO2, increase in CO2, is incapable of causing more than a very, very small change in atmospheric temperature by itself. So where are they getting this doom and gloom business then if CO2 is not really a big player in all this? And the answer is that in their computer models, they claim that CO2 increase will cause a small increase in temperature, and that will increase the amount of water vapor in the air, and the water vapor will be what causes this catastrophic change in global warming. But the problem is that water vapor isn't changing. Every time it rains, the water vapor content of the air changes. It's a very elusive fact, and there is no evidence whatsoever that there has been any increase in the water vapor content of the atmosphere over this period of global warming for about the last 30 years or so.
You say 95% of the greenhouse effect is water vapor, 3% is CO2,
right.
3.6%. What is the rest?
Oh, very, very small amounts of, in terms of greenhouse gases,
yeah.
Methane, sulfur, various other chemical compounds, which make up small amounts, and together they aggregate the rest of the 100% total.
So I have another question. Let us suppose that all over the world we were to cut CO2 emissions by 50%. What would happen in your opinion?
Nothing. And the reason for that is based partly on what I just said, that the effect of CO2 is so small, it's all about water vapor, not about CO2, that the CO2 change would have virtually no effect. And here's another interesting thing, that even if you suppose that CO2 does have an effect, you can calculate what that effect would be between now and the end of this coming century. And the change is so small that it would amount to way less than a degree, not 10 degrees, at the most optimistic viewpoint of CO2 that you could possibly take. And in order to change the CO2 composition in the atmosphere, there's probably nothing we can do to change it in any kind of a space less than about 500 years. So the total effect of spending trillions of dollars to try to reduce CO2 is going to be absolutely nothing. It isn't going to change the level of CO2 in the atmosphere in this coming century. And so why are we spending then, or wanting to spend, trillions of dollars trying to change CO2 if it's not going to have any effect? And, of course, the answer is, well, look at the politics and look at the money and look at the power, and you'll have your answer.
Did CO2 ever have an effect, either for cooling or for warming, ever on anything?
Oh, it does. And the question is not whether or not CO2 has an effect. CO2 is a greenhouse gas.
Okay.
Greenhouse gases tend to cause the atmosphere to be warmer than it would otherwise be without them. The question is not whether CO2 has an effect on climate. The question is how much. And there is so little of it, and it has such a small effect, that even though it has an effect, it is not significant. That's the point.
Okay.
There's no denying that it does have effect, but that effect is very, very small, and by itself cannot produce significant climate changes. And in fact, it's probably the other way around, because by far the greatest reservoir of CO2 is in the oceans, not in the atmosphere. If the climate warms up, the oceans emit more CO2 in the atmosphere. So, in other words, global warming causes more CO2 to be in the atmosphere than would otherwise be. Global cooling causes more CO2 to be taken in by the oceans, and CO2 goes down. And we know this from ice core studies, where during the ice ages, when there were huge glaciers all over the world, and sea levels were lower, we know that during those times the level of CO2 was low. And that when we went from an ice age into an interglacial age, when it was significantly warmer, that as the temperature rose, the atmospheric CO2 rose, but with a lag of about 800 years to the temperature rise. In other words, the temperature rise preceded the rise in CO2, not the other way around. If CO2 were causing it, the CO2 would have to go up first, and then the temperature would go up. But that's not what happened. What happened was that in each of the ice ages, after we went into an interglacial and the climate warmed up, CO2 rose on an average about 800 years later than the temperature rise, and therefore could not possibly have caused the temperature rise, and was in fact an effect of the temperature rise, because it warmed up the oceans, and the oceans then emitted more CO2.
Boy, this is really the opposite of what the story is, isn't it?
Oh, if you look at Al Gore's book, it's a joke, because he claims that, here are the ice ages and here are the interglacials, and the CO2 is a lot higher in interglacial, and so he somehow then infers that, this high CO2 is associated with warmer temperatures, and therefore if our CO2 levels now go up beyond what they were during the interglacials, that we're all going to fry. It's such faulty reasoning. It's totally illogical.
Well, let's talk about the fact that we're entering a cooling period. And for those that wish to prepare, do you think that we could build with different type of materials to be able to survive a profound cooling?
The cooling is not going to be catastrophic. It's not likely that we're headed for another deep freeze ice age like we've had in the past. And the last one was 15,000 years ago.
Why do you say that? You don't think we could head toward a little ice age?
Well, there's difference in the little ice age. That's an advance of local glaciers and a cooling of several degrees. A big ice age, which is what we had when there were continental glaciers all over the world, is much more profound. It occurs on a much longer time basis. Occurs over thousands of years, that sort of thing. And so you can't tell for sure that if you're headed into a cooling period, whether it's going to be some kind of modest cooling that's going to reverse and then go back into the cyclic pattern of warm, cold, warm, cold, warm, cold, or whether it's going to be deep, like the 1800 Dalton minimum or like the 1600 Maunder minimum that we've experienced, again, all without CO2 change. And so when you're headed down, we don't really fully understand what caused these very deep ice ages in the past, like 15,000 years ago. Don't have a very good handle on that. The best evidence now suggests that it's solar. There's no other global influence that could produce that kind of cold. So we need to know a lot more. Need to have a lot more data. But unfortunately, all the money for research is going in exactly the opposite direction, and none of it's going, or very little of it is going into these kinds of considerations. So how do you prepare for cold, and how do you know how cold it's going to get? And the truth is, we won't know till we get there. I've made 3 possible projections of how cold it's going to get.
Talk about that.
On the idea that the past is the key to the future, and that if we look at the past pattern, what could we project possibly into the future? Well, the first scenario is that we have a global cooling like we had between 1945 and 1977. That was a cool period, and the temperature in the northern hemisphere dropped about half a degree, globally about 0.2 of a degree. So it's not a big change. And then the one before that was cooling. It was 1880 to about 1915. And that was a deeper cooler. I was in most of the recorded temperature cold records were set in North America. It was a deeper cool period. Or it could be even deeper cooling like we had around 1800, when we had significant advance of glaciers all over the world, and we had all kinds of fairly bitter climate. It was responsible probably for the defeat of Napoleon and Russia and various other historic events. Or it could be even deeper than that, going back to the 1600s, 1650 to 1700, when a third of the population was wiped out by famine and disease because of the global cooling. And the even worse scenario was we drop into a full-fledged ice age. So we don't really know at this stage which of those scenarios we're headed for. The best guess now by the solar physicists that I work with is that we're probably headed for something like the Dalton minimum, 1800 kind of cooling, which was significant, but not a full-fledged ice age. But certainly would have an effect on crop production and the other things that are important to humans.
Would it eliminate a lot of the sun's input on the Earth? Give us a visual, if you could, of what a Dalton minimum might look and feel like.
Okay, a Dalton minimum would probably result in significantly colder winters. For example, looking back what was going on in those ages, in the age of Dickens, for example, the Thames River in England would freeze over, and they would have winter fairs on the ice on the Thames, which hasn't frozen over for a long time since then. You would have bitterly cold winters in the mid-latitudes, north latitudes of the world, and that would significantly reduce crop production. It would cause all kinds of changes in food production, that sort of thing. But it wouldn't be a total freeze-up, as you're not going to be overwhelmed by big continental glaciers or anything like that. The alpine glaciers would advance all over the world to positions lower in their valleys. These are mountain glaciers that flow down valleys. But you wouldn't have huge ice sheets built up or anything like that. But it would be significantly colder, and we would see a lot of significant changes. And if we go all the way back to the 1600s, it would be even worse.
How many solar physicists do you think understand clearly that solar input is one of the keys to understanding climate?
Well, there has long been a debate among solar physicists that of whether or not the sun is capable of causing significant climate change. And for a long time, there was a widely held belief that there was what's called a solar constant, that the output from the sun is always constant and never changes. We know now that that's not true. And since the last century or so, there have been various solar cycles that have been determined that occur on a periodic basis. There's about a 100-year cycle, a 200-year cycle, a 1,500-year cycle, and so on, and maybe more that we don't even know about yet. And so for those, the assumption was always that, well, the total output of the sun's energy to the Earth varies by a fairly small amount. And because of that, a lot of the solar physicists said, well, the solar output doesn't vary enough to cause big climate changes on the Earth. But what they weren't considering was the effect of the strength of the sun's magnetic field and the effect that had on shielding the Earth from radiation, which produces clouds, which produces cooling. And there's a new concept that was put out in the last couple of years by Henrik Svensmark in Denmark, who proposed that the big cause of changes from the sun was not in the amount of energy put out by the sun, but in the strength of the magnetic field, which controlled the amount of radiation, which controlled the amount of ionization in the upper atmosphere, which controlled the cloud cover, which is what actually drives the temperature. If you get a lot of reflection off cloud cover, the Earth is going to cool. And so there's been a major shift in the thinking away from a solar constant and towards variation of the sun's magnetic field to a whole new idea about the effect of the sun's magnetic field on global climates.
How popular is his new idea taking hold?
It's very popular among some physicists, and among other physicists, it's the opposite. So it's much like the global warming controversy right now among physicists. That is, some people say, oh, that's not important. Other people say, wow, that's the answer. So it's up in the air right now. But the data that Svensmark has suggested, he's proven this experimentally. He's done experiments that show that this is, in fact, what happens. So I think probably that what we're going to see more and more solar physicists looking at whether or not these changes in the magnetic field of the sun can indeed produce significant climate changes on the Earth. And that's a good thing. We want more and more data. But the concept is now out there, and it's a rather substantial departure from the old way of thinking, A, that the sun was always constant, and B, that it's not constant, but it doesn't vary a whole lot in its output, to now a mechanism which could explain climate changes. Because if you plot climate changes versus solar changes, you get a beautiful matching of curves. When the solar variation changes, so do global climates. And you can plot curves that go up and down, stack right upon one another. That is, the solar output and the climate changes. If you plot CO2 across that, there's no correlation whatsoever. None. Well, you could say that just looking at the last 500 years, there have been 40 climate changes, similar to what we've had recently. And I like to make the analogy: the only one that could possibly be caused by CO2, or any possibility, would be the last one, which is 1978 to 1998. And so if you're a big league baseball player and you have one hit in 40 at-bats, you're probably not going to make the team. And so we've had one possibility of CO2 causing a climate change out of the last 40, which is a really low percentage of correlation between CO2 and climate change.
And I'm going to ask you the tough question now. If, God forbid, you were wrong in your understanding of geology and the way in which you do what you do and see what you see and know what you know, would you acknowledge it to the public?
Absolutely. Science is about truth. And there's so much politicization of science now that is absolutely disgusting. The so-called CO2 dogmas have virtually destroyed the credibility of science to lay people, especially after the ClimateGate scandal turned up all these fraudulent manipulation of data. So it really is, I think, important to regain credibility, and the only way to do that, and the thing that I stand on, is the data speaks for itself. Look at the data, and if the data shows that that some preconceived idea was not correct, then you toss it, and you go with the data. You don't go with the theory. Right now, what's happening is the CO2 people are saying, we know what causes climate change, it's CO2, and we're not going to consider anything that is opposed to that. In other words, the conclusion precedes the data and supersedes the data. So if the data doesn't match their conclusion, then the data must be wrong. Well, that's not science. That's politics. What we need to do is to get back to the idea that you go where the data takes you.
Who are the biggest opposers of your work? What do people say about you on the internet, on Google? What are the attacks on you about?
Well, every time I publish something, publish data, what I think doesn't matter. It's the data that's important. When I publish data that suggests that CO2 is not the cause of what we're seeing in climate change, and every time I suggest that these are natural, reoccurring climate changes that have been going on for thousands of years, there are a lot of CO2-related blogs that immediately they call me names and issue personal insults. They never refute the data, and the idea is, well, you don't. If you can't refute the data, then you try to discredit the messenger. And so you will see blogs calling me an idiot and all kinds of personal insults, which of course is not very scientific. And most of the people who are doing this aren't even scientists. Although there are some scientists who will do that. For example, James Hansen, the head of NASA, has once suggested that people who disagree with him that CO2 is causing climate change, people like me, ought to go to jail for the rest of their lives as climate criminals. That's not science.
How do scientists do their jobs under this type of an atmosphere? No pun intended.
Well, I think that they work in certain areas of specialty, and they try to find out the truth about what's going on. And the difference is between those scientists who are objective, are saying, let's look at the data and let's go where the data takes us, as opposed to people who are now driven largely by money, unfortunately, who say, well, if I come to this conclusion, I'll have an open spigot of research funds of millions of dollars for the rest of my life, and I'll get promoted and so on. And so there's a strong bias there. And if they then do the other way around, they say, well, we know what the conclusion is, and you will see this. You'll see scientists say this, that the conclusion is now without possibility of change. And since we know what the conclusion is, any data to the contrary must be wrong. And those people are doing that right now. They're putting out all kinds of claims, and every time there is data that comes out that suggests that CO2 has nothing to do with significant climate change, then they will put out some outrageous thing, such as, the really cold winters that we're having now all over the world, both hemispheres, is caused by global warming.
Crazy
thing like that. And that's not science.
That's really lunacy.
Yeah, it's crazy.
You do research now full time, correct?
That's right.
How do you fund what you do? Because research is usually expensive.
In some cases, I have grants from government agencies. Most of that now has pretty much dried up because I am identified as a so-called climate skeptic or global warming skeptic, and therefore I would have no possibility, for example, of getting funding from the National Science Foundation. Now, the National Science Foundation funded my research for about 40 years, and I had something like 8 National Science Foundation grants. Nowadays, I wouldn't stand a chance of getting a grant because the people who are in control of the spending at NSF are the CO2 dogmatists who would not think of funding anything that could possibly cast down on CO2. So the bottom line is the kind of research that I'm doing now is relatively inexpensive, and I essentially fund it myself. It doesn't take a lot of money. Most of the data that I use is already available, and so it's a matter of putting the data together and see what it means, and also using data that are produced by other agencies, by other scientists, and that sort of thing. So I don't need a huge, big research grant in order to do what I do.
That's good. Well, I just want to thank you for being a guest on the show and tell you how much we appreciate your perspective. I don't think I've interviewed a geologist so far. You've been doing this for 50 years. That's really a huge commitment.
Thank you for the kind words. And my parting statement would be, don't believe the rhetoric. Look at the data. And you don't have to be a rocket scientist to look at the data and make up your own mind. And if you look at the data, I think it's very clear what's happening, what's going on, and whether or not we're headed for doom from warming or cooling. Time will tell. We'll know. For example, we'll know in another 10 years whether my prediction was right or not, whether we are in fact cooling. So my parting statement would be simply look at the data and decide for yourself. Don't believe anything you read or hear on the TV or the news media.
Ladies and gentlemen, we have been talking with, learning from, and listening to Dr. Don Easterbrook, who has been studying geology, practicing geology for 50 years, focused on ancient and modern climate change and abrupt climate change, looking at glaciers and ice core analysis. And what he says is the past in climate change is the key to the future. Thank you so much, Don, and we hope you join us again in the future.
Thank you. Be happy to.
Thank you.